Welcome, everyone. Today, we're going to peel back the cowling and get right into the mechanical heart of a small aircraft. We're going to find out exactly how the chemical energy locked inside fuel gets turned into the incredible power of flight.
You've probably done it, right? Looked up, seen a small plane, and just wondered, how in the world does that thing work? Well, today we're going to dive into that amazing piece of engineering and break down exactly what it takes to get a prop plane up and flying.
Okay, so first things first, we're starting with what's called the power plant. And it's not just the engine, it's the whole system, the entire setup that's responsible for creating the thrust that pushes the plane forward.
At the core of pretty much any small plane you see, you're going to find a reciprocating engine. And the name kind of gives it away. It's all about that constant back and forth, or reciprocating, motion of pistons inside. It's this nonstop movement that's the absolute key to turning the chemical energy from fuel into raw mechanical power.
Now, the most common design you'll find is the horizontally opposed engine. Just picture it, cylinders lying flat, facing away from each other on opposite sides. This isn't just a random choice, it's a super clever solution. It makes the engine really compact and lightweight, and what does that mean? A killer power-to-weight ratio and a slim profile, which is perfect for cutting through the air with less drag.
So let's zoom in on what's happening inside each of those cylinders hundreds and hundreds of times a minute. It's this beautifully timed four-stroke cycle. You can almost think of it like a mechanical symphony that creates nonstop power.
First up is intake. Simple enough, right? The piston moves down, an intake valve pops open, and the cylinder takes this big gulp of a super precise mix of fuel and air. It's basically loading up its ammo for what's about to happen.
Next, we've got compression. That intake valve slams shut and the piston shoots back up, squeezing that fuel-air mix like crazy. The analogy of coiling a spring is perfect here. You're just packing all that potential energy in there, getting it ready for the big show.
And boom! This is the magic moment, the power stroke. Right at the top, when everything is super compressed, a spark plug fires. It ignites the mixture, causing this powerful, controlled explosion that just shoves that piston down with incredible force. That one single bang is what it's all about. That's what turns the crankshaft and creates all the power.
And to finish it all off, we have the exhaust stroke. It's basically cleanup duty. An exhaust valve opens, the piston comes back up one last time, and it pushes all those used-up gases out of the way. And just like that, the cylinder's clean and ready to do the whole four-step dance all over again, instantly. Okay, so we've got this spinny crankshaft making all this power, but so what? How does a spinning thing actually pull a whole airplane through the sky? Well, that's the next critical piece of the puzzle, turning that spin into forward thrust.
The answer, of course, is the propeller. And you gotta remember, it's not just a big fan. Think of it more like a set of spinning wings. Each blade is what we call an airfoil, which just means it has that special curved shape that's designed to play with air pressure. So, just like a wing creates lift to hold a plane up, the propeller creates lift that goes forward. We just call it thrust, and that's what's pulling the plane right through the air.
Here's something really cool. If you ever get a close look at a propeller, you'll see that the blades are twisted, and there's a genius reason for that. The tips of the propeller are spinning way, way faster than the parts near the middle, near the hub. So that twist actually changes the angle of the blade from the hub to the tip, making sure the entire blade is working efficiently and creating a nice, uniform thrust.
So propellers basically come in two main flavors. You've got your fixed pitch prop, which is simple, tough. Think of it like a bike stuck in one gear. The angle of the blades never changes, so it's a compromise. It's okay for takeoff and it's okay for cruising, but it's not perfect for either. Then you have the more advanced constant speed propeller. This one's the real deal. It can automatically change the angle or pitch of its blades in flight. This lets the pilot set the most efficient engine speed for any situation, which saves a ton of fuel and really boosts performance.
Of course, all that fire and power doesn't happen by magic. An engine is a picky eater. It needs the perfect diet, that precise mix of fuel and air, to make that power stroke happen. So, how does it get its food?
Well, there are two main ways to feed the beast. The old school way is with a carburetor. It mixes the fuel and air together before they even get to the engine's intake pipes. It's a bit like making a big batch of punch and then pouring it out. On the other hand, you have the more modern fuel injection system. This is much more precise. It's like having a personal chef for each cylinder, spraying the perfect amount of fuel directly where it needs to go. As you can imagine, this gives you way better performance and efficiency.
But there's a really big catch with carburetors. They can ice up. And that's seriously bad news. When the fuel turns into a vapor, it gets super cold fast.
If the air is humid enough, that sudden drop in temperature can actually cause ice to form right inside the carburetor. This ice can block the airflow and literally choke the engine, leading to a sudden, dangerous loss of power. This is a huge reason why fuel injection is pretty much the standard for reliability these days.
So we've talked about the big parts, but an engine isn't a solo act. It's really more like a team. It relies on a whole supporting cast of other systems all working together. These are the unsung heroes of the power plant that make sure everything runs just right.
Let's do a quick rundown. You've got the ignition system, which uses something called magnetos to make the spark. Super important detail. They work completely separately from the plane's main battery, which is a huge safety feature. Then there's the oil system. That's the lifeblood, lubricating everything and pulling away heat. The cooling system, usually just air flowing over fins, gets rid of all that intense heat. And of course, the exhaust system, which gets all those hot, nasty gases safely away from the plane.
So when you step back and look at the whole picture, you realize a plane's power plant isn't just one thing. It's this incredible masterpiece of teamwork. Every single piece, from the intake all the way to the exhaust, has to work in perfect, lightning-fast harmony. It really is like a mechanical ballet, and it's what makes flight possible.
And that really shows you, doesn't it, this amazing dance of physics and engineering that's happening every single time a plane takes off. It kind of makes you look around and wonder, what other incredibly complex machines do we just take for granted every day? What should we break down next?